Ladies and gentlemen, welcome to the presentation called OPA for the Cloud Natives, presented by Philipp Krenn.
Hi. I know that we're the last talk before lunch. We'll try to finish before the others, so you can go first. I know that everybody appreciates that, so we'll see how we can get there. I don't want to rush too much, but we won't go too long. So OPA or Open Policy Agent, just a quick raise of hands. Who knows what OPA is? Okay, a few. Okay, so I kept this pretty basic. I think that's the right starting point for most, but we can dive into more complex stuff at the end if you want to. So this is not OPA. This is something that I have done in the past, and maybe some of you have done this in the past as well. So this is Ansible, and basically I had at the end of my whatever I ran, I had some checks in there to see, did I configure anything stupid? Did I open up SSH or SMTP or whatever to the outside world, which I didn't intend to? Who has done something like that in some config management scripts? 2, 3, a few. Okay. Do you think this is a good idea? Or let's ask differently. Maybe this is, or if you have nothing else, this might be an okay idea, but this is maybe not the thing that you really want, because it's very closely tied to your Ansible implementation, and whatever you changed up somewhere else in the script, you might just change it down here. So there are various reasons why this might not be such a smart idea. It's probably better than nothing, but OPA in the end, and we'll take a couple of steps until we get there, will hopefully give you a better alternative to that. I mean, this is better than nothing in my opinion, but it's not really what you want. And I want to show you a bit why you want more, or what is kind of like the difference that you want in there. So, security-wise, most of the time, this is us, and we're saying this is fine, right? You don't have to raise your hand, but for most of us, this is kind of like the state where we are, where we say like the world is on fire, but it's kind of okay, or as it always has been. What we want to do, though, to kind of like not make it that bad, is we want to decouple that policy that I've shown you before, that to make sure we cannot SSH into an instance, and the change control, how we configure that. We probably want to decouple that, so it's not just like one single place where you change it, and if one person changes it, nobody can review all of those changes in your config management, and it's very easy to overlook that other change that you change that check at the end, for example. So you probably want to decouple your policies, what is allowed and good in your services or okay, from actually how to get there. You also want to constantly run those policies. Who can SSH into their production service? Very few would dare to raise their hands. So oftentimes it's just like, let me quickly debug this, or let me quickly fix that, which you shouldn't do. And we can talk about immutable infrastructure, but in practice, I think in many places you can still SSH into production and change things, even though you shouldn't, or you can deploy something for debugging that you maybe shouldn't. And that's why you want to constantly run these policy checks that you haven't done, or nobody has accidentally done something that they shouldn't be doing. And it's not even part of your config management, and it didn't go through a pull request and nobody reviewed it, but somebody just tried to fix something or test something, and then it might linger around in your production infrastructure for a long time. That's why you want to run these policies to check what is actually happening and what is allowed constantly, to find those things very early on. And you obviously want to manage that as code. I don't want to say GitOps, because then there are big discussions what is and isn't GitOps, but you want to have this somewhere in version control and not just behind the UI, and you want to have this going through pull requests and reviews and whatever you want. And you want to have those insights into policies all the time. So you don't just want to say like, oh, my Ansible playbook ran successfully and it passed that step where it actually checked if I didn't open the wrong port, because A, you could just abort that operation if you didn't want to, and B, there might be this drift between production and what you're testing, and you want to constantly run this to see what are the policies that I have configured and what I want to have, and has that run in the past, I don't know, hour or so to check if I really have only the allowed stuff in there. So that's why you want to have like these two decouplers then running separately. Which is also very nice for compliance and auditing. I'm not sure how much fun you have with compliance and auditing, but normally nobody does. Ideally, you have a good policy set up that you can just pull up for the auditors and say like, yeah, these are all the checks that we are running, and this covers most of the things that you're looking for anyway. This ran the last time, I don't know, 45 minutes ago. And then it's kind of quick to be done with that. Otherwise, you will need to do lots of manual reporting to check if you're doing what you should be doing. And taking one step further back, why are we doing all of this? So I always say there are 3 levels of security incidents that you could have. There's the for your information, there's the WTF, and then there's the oh my god. And we don't want to have that oh my god, which happens unfortunately far too frequently. I don't know. It's Log4Shell or whatever you have that is like one of these oh my god vulnerabilities. And the oh my god category is normally that you learn from the press or your users that something has gone wrong, and you don't want to have that. The second level is that somebody asks for a ransom because they encrypted all your data or threatened to leak it. You also don't want that. The next level, that's maybe just a WTF, or depending on how much money you have in the bank, that your cloud provider's bill is very high because somebody started mining cryptocurrencies, which is totally inefficient on cloud instances. But if it's your bill, then you can still do that. Sometimes you just learn it yourself after the breach, but your policies caught it or figured out that something was wrong or whatever you have been monitoring. Ideally, you find it yourself and you can prove that there was no major harm because you have enough insights into your environment. But the ideal state, and this is again where we try to come back to OPA, is you find something where you open a security hole, or there is a potential security hole, and your policies catch that before anybody can actually get to those. So your policies are faster than potential attackers. That's kind of like where we ideally shift that. I mean, it's this constant discussion about like shift left. You want to find stuff earlier and not just like retroactively look at them, but during the development or when you raise the pull request, you already catch potential issues. And that's exactly where we want to move with OPA here. And by the way, tribal knowledge is not security. So tribal knowledge is you knowing this service should have access to these other 3 services, but nothing else. And you manually either check that, or you know when you review a pull request that you make sure that this is still the case. But that is not a security policy that doesn't scale, and that probably breaks at some point. Or at the latest, when the person with the tribal knowledge leaves, then nobody knows anymore what you want to have or how your services should be structured. So it needs to be explicit in a policy. And that's exactly where OPA as a policy comes into play then. So we want to avoid that everything is on fire and everything is terrible and we end up here. That's kind of like where we want to go with this entire OPA topic. But there are no silver bullets, even though lots of vendors try to sell you silver bullets. But there are none. OPA is just one more thing in your toolbox to solve them. And we can now look at like what is in there and what it can do. So it started in 2016, so it has matured quite a bit. It's CNCF incubating, and it has, I think already 2 or 3 years ago, for example, it has been quite widely used at Netflix, Cloudflare, and others. For example, Netflix had the requirement they have, I don't know, 1,000+ services or whatever, running all over their infrastructure. They're very AWS heavy, and they wanted to have something that would scale to their number of services and users, to constantly check that everything is configured in the way they want. Because they have so many developers and so many services and so many users that nobody can keep that in their head and know what is allowed and what is a good policy and what should happen and what shouldn't happen. And OPA has, on their start page, has this very nice graphic where they they show like all the things that they can work with. So it can be from good old SSH, that nobody can SSH into your instances, or that you need a certificate and not just a password. It can run against Kubernetes APIs or any other APIs, but it can also tie into your CI/CD, a service mesh. These are all the things where OPA kind of like tries to tie into, where you can create a dedicated policy to make sure only stuff that you explicitly allow or want is possible. And that can be on the infrastructure level, like simple as SSH, but it can also be more higher level in your application to say a specific user should only be able to see their own data, but not the data of their colleagues. Or you can only change your own data, but your colleagues cannot change your data. All of those can be expressed in policies in OPA that you can keep explicitly outside of your application and constantly run and check. Why don't you want to put these policies into your application, by the way? Because it's A, probably a mess. B, if it's in the application, it's probably just covering the application, and what OPA is trying to do is trying to cover infrastructure, application, and pretty much everything you can reach. And thirdly, it's often far too easy, what I've said with Ansible before. If it's all in one place, you have one big pull request, you change something in how something is done, and then you also adjust the policy and nobody catches that. So if you keep the policies separate and then people pay much more attention to any changes to those, you have a far better chance of catching that something is going wrong there. How OPA is generally structured. So you have OPA as the binary that runs. Your service, that can be any service that you're trying to secure or protect. That could be Kubernetes, a server with SSH, it can be your application, whatever you want to have. We have policies which are written in Rego, which looks a bit like JSON pretty much. And then you can provide additional data as JSON, and we'll walk through a concrete example in the next few slides. So what OPA is basically doing, it has its policies and the data loaded in memory. And it then can check against the service and then make a decision, did this check or policy that I've configured pass, or did it fail my service? And that could be whatever you have configured in terms of security. So far, so good? Any questions? No? Cool. Let's look at that, and I hope that is that large enough for you to see? Otherwise, I can open it in a text editor as well. Maybe this is easier to read. Okay. My slides are just marked on. So what I have configured here is I want to configure that I can only read my own data. So basically, for a specific URL endpoint, I want to ensure that only a specific user, for example, Philip, can read Philip's data or change Philip's data. And the policy that I can define here is I can say allow true. So this is what is allowed. If you have another combination that would fail, that I do a get on the my data endpoint, and then I make sure that the employee ID that uses or is part of that data path matches the logged in user employee ID. So this is a very simple example that those two match here, but that makes the configuration a lot simpler. So with this, I make sure that only the employee can get their own data. And then what you have as the input for the test would be you do a get on the my data endpoint with the user Philip, and the logged in user is Philip as well. So then this would pass because these two match here. Now, I keep the same policy as before, but this time the user Peter or whatever tries to access Philip's data. This would then obviously fail because those two wouldn't match, and then you would have a failure here. You could also make this a bit more complex by saying you want to read your employees' data. So for example, you're a team lead and the people on your team, you should also be allowed to read their data. What we are doing here is we're having an additional allow here where it's get my data, and then the employee ID needs to be in a list of data where you have a relationship manager of for that employee ID. So then we have this data, and just to go back to this slide, that was the policy, and this is the additional data that I'm adding here. So this can, for example, provide some mapping. This is also if you have some role-based access control, you could always inject that additional data, how groups are structured. I have a very simple relationship now where I say, this person is the manager of this other person, and then they can access that person's data. And then I run it through OPA, and then it will say, yes, this passes or it doesn't pass. So for example, I can see now Philip is the manager of Peter, and Kelly is the manager of Philip. And with that, I can then run through that and then check if here the employee ID of the data is Philip, and then the only person that can access that one would be Kelly, because only Kelly is the manager of Philip. Or Philip could access the data of Peter, but not the other way around. And right now, as it is configured, this is also not transitive. So this is only like this maps to that, but it doesn't do a transitive relationship here. So far so good on simple example of a policy. So this is what you can express in a simple policy that's a bit small here. Another simple example, but this is maybe a bit more real world for your Kubernetes for the Kubernetes users, is that we say we only trust a specific image registry. So for example, we run our own registry, and then we say we only want to run Elasticsearch or Kibana, whatever images coming from elastic.co, whatever, and not from any other registry. And that is basically what we are expressing here. So we're denying any pods running, and then we are getting the spec of that specific container, and then we check that the container image starts with that URL here, or the registry where it comes from, and otherwise it gives me a message and says like, well, it's not coming from an untrusted registry, and then I don't allow that. So yeah, this is not just JSON. This is a bit more complex with Rego and the packages and imports that you can use. But this is the way that you can structure these rules to say like what is allowed and what isn't allowed. So it could be within the application, or it could be something like Kubernetes. And Kubernetes is a great example because you just query the API server and you can get any information that you need. And based on that, you have the policy outcomes or not. In another example here, I say that only a cat owner can update the pet's information. So for example, here I say I only allow it if this is a put operation, and then there's a pet ID, and then I say the owner of that pet is, well, only if that is the owner of the pet, you can actually do the put on the pet. This is pretty similar to the example that we had before. And again, we would need that additional data where we have that mapping, like which owner owns which pet. And then we can kind of like resolve that policy, and then it would give me yes or no. So you can feed that with any input parameters that come in, and then say, yes, these are allowed or these are not allowed. And then it would tell you, yes, the policy passes or not. Another nice example that I saw recently was from DoorDash. I think they're big in delivery, for example, in Asia, where they have on their pull request, they add a comment on their pull request that say like, this pull request does not pass some policy check. For example, here they open SSH without source restrictions, which does not pass their policies. And that looks then a bit more fancy. So you as the user open a pull request on GitHub or wherever, and then it generates a Terraform plan. So Terraform is one of the many integrations that OPA has. So you can just generate the Terraform plan for that. There are the DoorDash rules are stored in Amazon S3, and then that worker they have can fetch the policy. It checks it against the policy or the OPA agent. Like with this plan, does it pass the policies that I have defined here? It tells me, yes, this passes or it doesn't pass. Then it actually runs that against Terraform, and then it tells me, yes, this passes my Terraform check, yes or no. And based on that, it will allow my entire action. So here the comment comes back. this would actually trigger it only if it passes, and then it can only then can it apply the Terraform change. So it catches any bad Terraform configuration before you can actually deploy it, and that's how to stop it. So far, so good. Cool. The easiest way to get started with OPA is they have a playground called Play. And I'll quickly show you how that looks like. Is that large enough for everybody to see? Or maybe I can make it a little larger. So if you go to the playground, this has the hello world. And what you want to do is we want to evaluate the input is message world. And my policy says it passes if the input message equals world. So if I evaluate that, it will tell me here that this is true. If I change my input to hello, then it says this doesn't pass, this is false, but if I change my policy again, then those two would match again. I mean, this is really just a hello world of how a policy works or how you can apply it. But they have a couple of more fun examples. For example, coming back to the Kubernetes example with the image safety, here their example is Huli, whatever registry that is. And this here, the input you can see, this is from the Kubernetes API, where we can say, this is where the image is coming from, but this image here is MySQL. So if we evaluate that, it will tell me MySQL does not come from a trusted registry, because this is from Docker Hub directly, whereas this comes from the huli.com registry. And I could just change that here. Let's assume that could also come from Huli, and then it should pass my policy, and then you don't have any deny rules anymore. You can also do other examples. I think this one is kind of interesting. Here we are making sure that every pod that we have running has a specific cost center label. So basically we are making sure, I don't know, it starts with C code or CC code dash, and then whatever cost center this is against. And if a pod doesn't have that label, it will fail the policy. Again, this is very simple, just to see if this will work or not. So here we have a cost center label with a fake code. So it has the right label, but it doesn't follow the format that we are requiring. If I run this, it will tell me, okay, this does not comply to the naming scheme. If I change it to, I don't know, works, then that policy passes. And all of those, like, there are similar ones for access control, which are relatively similar to what I've shown you before. There are examples for Envoy, but you can easily build your own for pretty much anything. So anything that has an API, you can check against here.
So I have a question.
Sure, please.
So in this last case, I would have to describe the pods manually, right? And provide the data that is, how is it called?
This one here? Yes, I mean here the policy says I need a label that is called cost center, and it needs to.
Meaning the providing the input. The input comes from me, right?
The rego, the rule, the policy.
No, the input on the top right.
No, the input, that is what is coming from the Kubernetes API then.
Yeah, but so this OPA just gathers the data by itself, or just
Well, you need to tell it where it gets it from. So okay, I'll add that to the slides afterwards. It's actually a good question. Just to make that sure. Okay, my internet is very slow. This is missing some arrows. Yeah, now they're appearing. So you can run this as a service against an HTTP endpoint. So if your service in that case is the Kubernetes API, which runs HTTP, that is where the input is coming from. or you can run it as a library where you just embed it in a Go binary. But what I'm mostly talking about here is this. Basically, what in the complete configuration, what you would need to do is you would need to say what is the input source for the HTTP request, and then you evaluate against that. This is just slightly simpler because here I provide the input manually, so I don't need to have the Kubernetes cluster running with that specific configuration, but I can just simulate this is how my policy works with this rego.
I was wondering if this OPA has just some REST API that...
Yes, it just does the HTTP call. Like you need to tell it, this is where the Kubernetes API is running, these are the credentials, and then it will fetch that object, and then it runs the policy against it.
I was thinking, I was getting the idea that I'm just getting the input from the data from the Kubernetes and providing it as an input manually.
No. It continuously runs against whatever endpoint you define. So for example, since I work for Elastic and we have Elasticsearch, open Elasticsearch instances are also a common thing, where you could, for example, say you have a policy that says you don't allow unauthenticated access to Elasticsearch. And that would be another example where you say this is the endpoint where Elasticsearch is running, and then you have a policy that says the authentication without credentials fails, otherwise the policy fails, and you continuously run that against the endpoint. So no, you don't need to do that manually. You can just provide, so what you do provide manually or have to provide in some form was that data here. This here, if you have like this mapping information, that you will need to provide explicitly. But for example, if you have an HTTP service, you can just run the HTTP request against that constantly, see what is currently configured, and then fail or succeed. That made more sense? Cool. Anybody else? Yeah?
I have a question regarding the data. On your example, it was quite, the data was small. Do you have experience with larger data sets? Like, do you use them in...
So it's loaded in memory, so it's generally fast. I mean, with modern machines, like a couple of megabytes are fine. I don't assume I hope you won't have gigabytes of configuration or mappings.
I was thinking rather like the users, for example, because we have some use cases when we need like not the company users, but we were thinking about
the end user where you potentially have thousands of users. But I mean, thousands of users, let's say 10,000 users, each mapping has 20 bytes. That's still 200 kilobytes. So
you haven't used it like in these use cases?
So since we're a tool provider, most of what we do is more like on the infrastructure level where you don't have like 1,000 users mapped. I think that, or I've not really seen it as a major complaint. I mean, or OPA is like one of the design goals was to make that easy and fast, and that's how Netflix is using it. I think they have more problems like that. But you also don't need to, but I mean, you don't need to embed the full user set. You just need to have the representative set to make sure, yes, to make sure this type of access pattern works. You don't need to encode your entire user base into that. But also on modern hardware, like, I mean, JSON is not super compact, but it's not XML in terms of size, and yeah, but in the end, you want to construct like the flows that you can test them, but you don't need to embed your entire user database. And it was generally built to perform well on anything like that. And from what I've seen from Netflix with thousands of services, that is fine. But of course, that depends on like how many policies they run. But no, I don't think that's the main concern there. Yeah. Yes. So I know that we have wrapped all of this in a bigger binary that runs the open policy agent, and then we can like distribute that with the rules and everything. I'm not sure if the base distribution has that as well, or if, because while this is a CNCF standard, there are multiple vendors involved in this, and then they all wrap the open standard to kind of like run it their way. And like what you have is like you have the record policy, the data, and the binary how to run it, but then how to distribute that and how to collect the information and how to visualize how that is going on. That is then based on like vendor-specific implementations normally. Because I haven't really shown you that, but this is like where is it? Styria is the company that started this. These are like the main player or one of the big players, but there are multiple other companies involved in that have their own implementations on that open standard. So that is again then I think where the different vendors come in to have different implementations how to distribute the data. For example, we acquired an OPA company a year ago, and there we have that full mechanism where we have an elastic agent that we can roll out, and that agent then can run OPA policies, and then it distributes what we have configured. So that is then I think more on the vendor side, how to roll those out, but the base foundation is shared by everybody, but then there's of course a differentiation by vendor on top of that. Anybody else, or all good for now? Cool. So why do I even talk about that? Like I said, we bought the company a while ago in that area. So we have started to embed that in our product. So what our take looks like, and okay, let me show you the screenshot because the Wi-Fi is sometimes a bit shaky. For example, we have, we call it, I don't know why, but the push to dashboard, and we have that for cloud and Kubernetes, and that can check various things. So for example, it can check your IAM policies, your S3 storage policies, how you have configured networking. CIS is a standard for Kubernetes, like how security is configured there. And then you get like a policy out of there that says like, this many policies fail, for example, and this is like your compliance level on terms of like so many policies passed and so many policies failed, and how is the development over time. So that is then where the vendors basically come in. You have the open standard that you could take the rules and apply them with any vendor, but then the different vendors have that kind of like wrapped in a package that you can use and have in your bigger security picture, because you probably still want to correlate that with, I don't know, in our case, for example, the logs that you have on your system to see who actually accesses something and have a bigger package around that. We have a security seam where you can include that, so it's just like one of many data signals and sources that we try to run. What that looks like, and I hope that has loaded successfully. Please, internet. Okay, 70 kilobytes. Okay, slowly but steadily we're getting there. No, not on this one. Come on, load my data. Okay, so here, for example, you can see that 86% of our policies pass, and then you can see we have for pods or for an API, we have specific rules, we have RBAC, all of those are configured, and then you can see, for example, how did the settings for my Kubernetes cluster work. And then you can see on my pods, whatever are the failures on that pod, and this one will tell me, okay, you have given the net raw capability to a pod, which is generally not what we want, or we have a policy against that, and which is also in the CIS standard, which is like a framework to evaluate Kubernetes security, and it would then tell you like, okay, this is one of the rules that is failing. And that is what is running. We currently do not have the option to run custom policies yet. We'll get there soon. But we are running, or this is basically a predefined wrapper around it yet. To roll out custom policies, we'll get there in the future. That is why I generally care about OPA or what my involvement is there. So I hope we kind of made it clear why we don't want to run this from the application directly. I mean, you can have some, or your security implementation is in the application, but you don't validate it from the application. You want to have those rules run outside. Same thing for your change management, like Ansible, Chef, Puppet, whatever you're using. You don't want to only have your security checks in there, but you want to have like that running outside continuously, reviewed differently to find out why something is changing or breaking. And I hope I made it clear why OPA and what it can give you in terms of like what policies can do. And because almost everything has an API nowadays, from Kubernetes to your Amazon setup to whatever else you're running, your application, most of those just run through APIs, so you can run all of those easily from OPA to figure out what is allowed and what isn't allowed. Did all of that make sense? And are there any other questions? Yes? As HTTP. Right, but I mean that's relatively, I mean that the data input is for the HTTP API, and then sorry, yeah, I mean, yeah, we run it as a daemon set normally that runs at one place and then queries the Kubernetes API. I mean, there's one Kubernetes API server, so we query that. Does that?
I was thinking of applications for your last course. So whenever your customer is calling, for example, your API, and you can evaluate his permissions, let's say.
Yes, so you would try to run it as locally as possible. So the general setup is that you don't want to run this, if you can avoid it, you don't want to run this over the network, but you want to have the policy check on the same host. So if you have a service running there, then you would have like a sidecar or whatever the concept is that you're running there. But if it's going against the Kubernetes API, or depending on how you run Kubernetes, but it might be a managed service, then you just have the API, then you couldn't run it directly there, then you run it in one place and just run it against the API server. But with an application, yes, you would normally run it as a sidecar or daemon set, whatever you have there. So you would have, for example, one pod running on every host to check whatever is deployed on that application server or on that Kubernetes node. Yeah, maybe. Okay. Anything else? No? Cool. Then, thanks a lot and enjoy lunch.